Hello everyone and welcome to GLB Productions. In this video, I'll be showing you how to connect a power amplifier to a set of passive loudspeakers. Now in all PA systems, there are certain common components. All PA systems have inputs, for example, vocal mics, guitars, keyboards, and drums. These inputs are generally connected to a mixer or a mixing console. We have an example here. This is a Yamaha MG series console that you've seen in a number of my videos. Mixing consoles are then connected to loudspeakers. They may be connected through a graphic equalizer or parametric equalizer, but in simple PA systems, the mixing console will be connected directly to the loudspeakers. In today's world, you have the choice of two types of loudspeakers. You have active loudspeakers and passive loudspeakers. Active loudspeakers, such as the JBL Eons and the Mackie SRM series, have the power amplifier built into the back of the loudspeaker. And as a result, you only have to deal with connecting one unit. Now, in the early days, all loudspeakers were passive and required an external power amplifier, such as the unit that you see below the mixing console here. In the case of passive loudspeakers, the mixing console is connected to the power amplifier, and the power amplifier is then connected to the loudspeakers. And this is the process that we're going to focus on today. So let's begin by having a look at the equipment that we're dealing with now. Now, I need to stress that there are many hundreds of brands of power amplifiers and loudspeakers. And as a result, the advice that I'm going to give you today in this video has to be somewhat general, and you need to apply it to your specific situation and the equipment that you're using. Fortunately, just like analog mixing consoles, power amplifiers and passive loudspeakers have been around for a long time, and generally speaking, the controls and signal and indicator lights on each one are by and large the same. Most power amplifiers today are either 1 or 2 rack spaces. This refers to the height of the front panel. If you're working with an older system, you may have some that are 3 rack spaces high, or even some of the very old 4 rack space high power amplifiers, especially some of the PVs. They're still around today just because they were so well built. On the front panel, you will usually see a series of louvers or grills. This is to allow airflow through the amplifier. It's very important that these not be blocked. Some of them will have foam air filters, others will just be open. Amplifiers use cooling fans to draw air through the chassis to dissipate heat. Amplifiers generally will ventilate either from front to back or back to front. Some crown amplifiers actually ventilate from front and then they expel the hot air out of the sides of the chassis, but that is a relatively unusual design. It's important that when you are racking amplifiers, you not mix the front to back with the back to front types, because if you do, then generally the hot air will get recirculated. In other words, some amps will blow hot air out the front panel, which will then be drawn in by the amps that draw air in the front and blow it out the back, and vice versa. If amplifiers overheat, they generally will shut down, which means the end of your show and generally the end of your job. So you have been warned. If we zoom in on the front panel of this amplifier, you can see that it has 2 channels. Almost all power amplifiers nowadays have a minimum of 2 channels. You will occasionally encounter something that is called a monoblock amplifier. These are more common in home stereo and home theater setups. Most modern amplifiers have at least 2 channels. You will have amplifiers that have 4, 6, and even 8 channels in a single chassis. Some of the Lappgruppen amplifiers spring to mind that now have 6 or 8 channels. You have level controls. These may be a physical potentiometer like you see here, or they may be some kind of digital encoder. Then you will have something to tell you that the amplifier is receiving signal, something to tell you that you are clipping the input, meaning that you have distortion or that the amp has detected distortion, and finally some sort of protect or a light that tells you that the amplifier is in trouble and has muted its output. You may or may not have status indicators. You can see at the bottom here you have an indicator for parallel mode, one for crossover active, and one for bridge mono mode active. I will explain all of these terms in due course. On the right side of the front panel, you can see there is a power switch. On some amplifiers, the power switch is on the back. On other amplifiers, there's no power switch at all, and it's just powered on when you connect the power cable. You can see that this amplifier has a little amber light there that says standby. What that means is that the power supply is energized, but the amplifier has not actually been turned on. Now, when you switch the amplifier on, you'll notice that it has a startup sequence. The protect lights come on, and in this case, it does not indicate a problem, it just indicates that the amplifier is starting. After a while, you can see they've gone out and the amplifier is good to go. There's a blue light there and the standby light has gone off. Power amplifiers are generally fairly simple pieces of equipment, and as long as you don't let them overheat, they generally will cause a minimum of fuss. Now let's take a look at the back panel of this amplifier. As you can see, you have the heat sinks here, as well as another set of louvers. This particular amplifier uses front to back ventilation, so the hot air will be coming out here, hence why the heat sinks are located towards the back of the amplifier. On the right side of the back of the chassis, you have the inputs located. There are two sets of inputs because it's a two-channel amplifier, and as you can see, the feature set is fairly comprehensive. You have XLR, TRS, as well as RCA for home or commercial use. Next to the inputs, you have three sliding switches which are recessed into the panel so that they can't be adjusted accidentally. You have the amplifier sensitivity switch. This controls how much gain the amplifier gives you. You have crossover on or off. This particular amplifier has a built-in analog crossover. Not all amplifiers have this feature. And finally, you have the mode switch, bridge, parallel, and stereo. These will all be explained subsequently. Panning across to the right-hand side of the amplifier, you have the outputs. These are what are called binding post outputs. Basically, there's a hole in the side here, and you unscrew this, you put in bare loudspeaker wire, and then you twist these down, which clamps the wire against the terminal. Next to them, you have speak-on connectors. The speak-on connector has become the de facto professional loudspeaker standard, especially for mobile applications. It is safe and it is also very reliable. If you are using an older amplifier, you may have a connection via a TS or guitar type jack. Make sure that you do not mix up your amplifier cable with your normal guitar jacks, even though the connectors are the same. You may have connection via banana plugs or spade lugs, or even just a bare wire which is screwed into a terminal strip. You'll need to work out what your particular amplifier uses. Here's the power cable. Now, some amplifiers will have an IEC connector on the back panel, but most higher power amplifiers will have the cable hardwired into the amp chassis. This is to prevent you using a really skinny power cable that may melt under the load that is created. It's important to give power amplifiers due respect. These generate voltages that can be life-threatening if you connect to them in the wrong way. Always treat a power amplifier with the same respect as you would treat any live electrical circuit, because people have been killed in the past by malpractice. And now a look at the back of the loudspeaker that we're going to be dealing with here. This happens to be an Eckler Verso 12 loudspeaker cabinet. You can see here it says Verso 12 passive loudspeaker cabinet. If you're in any doubt as to whether your loudspeakers are passive or active, the best way is to look and see if there is an AC input on the back of your loudspeaker, similar to that on your mixer or other electronic equipment. If you see one, then it's active. If you see these speak-on type connectors, the same as the ones on your power amplifier, then it is passive. Now, the first step in connecting a power amplifier to a passive speaker is to ensure that your amplifiers and speakers are matched. This is something that you only need to do once, and if you buy your system as a system from a professional outfitter, this process should have been done for you. Nevertheless, it's still good to know what exactly is involved. So, step one is to determine the power handling capability of your loudspeakers. This is sometimes posted on the loudspeaker itself. So you can see that it says here impedance 8 ohms, power 350 watts RMS. It's important to understand that this does not mean that you have to use a 350 watt amplifier for this loudspeaker. There's always a range of power amplifiers that you can use, and the best way is to consult the documentation that comes from the speaker manufacturer. So here I've printed out from Eckler, and you can see it says there Verso 12 between 350 and 700 watts. Now, what about if you don't have this information? How do you know what sort of power amplifier to use? As a general rule, you want to use a power amplifier that provides between the RMS and double the RMS. So a power amplifier that provides between 350 and 700 watts RMS. The next step in our process is to verify the impedance of our loudspeakers. As you can see, this one says impedance 8 ohms. Most single woofer designs, so 1x10 with horn, 1x12 with horn, are 8 ohms. Some of the larger loudspeaker designs, especially the double 15 with horn enclosures that are very often used by DJs, as well as the big subwoofers, can be 4 ohms. So it's really important to check that, because that will affect how much power your amplifier is able to deliver to the loudspeaker. Now that we've determined the power handling as well as impedance of our loudspeakers, we need to double check the power delivery of our amplifier into that impedance. Once again, we need to consult the specification sheet that is provided with the power amplifier. We know that we are dealing with the XLA 1600. You can see there's a couple of other models in that series. Now, on this spec sheet, it lists power into 4 ohms, 8 ohms, and 8 ohms bridged. We know that our loudspeaker is 8 ohms, therefore we want to look at the 8 ohms stereo. And for the XLA 1600, it is 450 watts RMS. We know that for the Verso 12, we want an amplifier of between 350 and 700 watts into 8 ohms. So this amplifier appears to be a great match. Now, so far we've only discussed using one loudspeaker per amplifier channel. In larger systems, it's common to run more than one loudspeaker off each amplifier channel. So for example, you may have one amplifier at front of house and you're using channel 1 to drive 2 loudspeakers on the left and 2 loudspeakers on the right. In that case, how do you work out your power handling? The first thing is you need to work out what is the combined impedance of all the loudspeakers that you are loading onto each amp channel. The formula for this is the impedance of one loudspeaker divided by the total number of loudspeakers, assuming all loudspeakers are the same. So 2 8-ohm loudspeakers gives you 4 ohms, 4 8-ohm loudspeakers gives you 2 ohms, so on and so forth. So let's say that we were driving 2 of those Verso 12s off each channel of the XLA 1600. Would we still be okay? Going back to our documentation, you can see that we would now have to consult the 4 ohm stereo line because 2 8-ohm loudspeakers result in a combined impedance of 4 ohms. The amplifier delivers 760 watts into 4 ohms. Each loudspeaker would get exactly half of that. 760 divided by 2 is 380. We know that our loudspeakers can take anything between 350 and 700, therefore we are still okay. Now all power amplifiers have a minimum specified impedance below which they will generally have thermal issues. On this particular power amplifier, it's 4 ohms. So could I run 4 Verso 12s off each channel? The answer is no, because 4 8-ohm cabinets gives you a combined impedance of 2 ohms and the power amplifier would shut down. This is especially important when you are matching subwoofers to amplifiers because many subwoofers have 2 drivers in each cabinet and are often 4 ohms. So you will find that you need to do the math and be aware of the specifications of your system. Now the next step in our process would be to connect the mixing console to our amplifier, and I have the MG124CX here. Obviously, in a real setup, the mixer would be located at front of house and the amplifier would be either in a rack nearby or in a rack near the loudspeakers, but this is just for demonstration purposes. So in order to understand how to connect your mixer to your amplifier, a little bit of understanding of amplifier modes is required. Amplifiers generally operate in 3 different modes. The first is referred to as stereo mode. This is the most common mode. And in this mode, input to channel 1 of the power amplifier goes to the output of channel 1. Input to channel 2 of the amplifier goes to the output of channel 2. So it operates as 2 independent channels. They can be used for left and right, or in some smaller systems you may use channel 1 for your front of house loudspeakers and channel 2 for your monitor loudspeakers. It's up to you. There are 2 identical independent channels for you to use however you want. The second mode is called parallel. In parallel mode, input to channel 1 goes to the output of both channels and input to channel 2 disappears. In other words, the input to channel 2 is not used. This is used typically when you are driving a large number of loudspeakers from a single amplifier. So in a slightly larger system, you might have one power amplifier which is dedicated to front of house right loudspeakers. And you're using that amplifier to drive maybe 2 or 4 loudspeakers on that side of the stage. The third mode is bridge, or sometimes called bridge mono. Now in this mode, the 2 amplifier channels work together to drive a single large speaker enclosure. Channel 1 pushes and channel 2 pulls, figuratively speaking. Now this setup generally requires special cabling and is beyond the scope of this video. It's usually used in conjunction with subwoofers. So today what we're going to do is we're going to hook up this setup in stereo mode. So we confirm that the mode switch on the bottom of our amplifier is in stereo, and then we proceed to run an XLR cable from the left output of our mixing console into input number 1 on our power amplifier. And then we do the same for our right. From right output of our mixing console to the input of channel 2 of our power amplifier. Now, before we move on, a word about daisy chaining amplifiers. I remember that one of my subscribers asked me, say I have my mixing console and I need to connect to 4 separate amplifiers. How would I do that? There's 2 ways to do this. The first is to use different outputs from your mixer to connect to each amplifier. So for example, some mixers have 2 sets of main outputs, one on XLR and one on TRS. You could use the XLR outputs to connect to 1 amp and the TRS to connect to a second amplifier. The other way of doing it is to daisy chain the amps themselves. You'll notice that this amplifier has XLR inputs as well as TRS and RCA inputs. These are all connected internally, so the unused inputs can also be used as outputs to the next amplifier. In order to accomplish this, you'll need an XLR to TRS adapter cable, which looks something like this. This one has seen better days. It's been used for many years. And what you would do is you would simply connect the TRS to any unused input on that channel, and then use the XLR male to connect to the next amplifier, and you would just repeat this down the line. On the better amplifiers, these inputs are buffered, so there will be no concerns about impedance. Now let's have a look at connecting the amplifier to the loudspeakers. With all modern amplifiers, you will need a set of good speak-on loudspeaker cables. Now, a speak-on cable will have one of these on each end of the cable. And you can see there it says speak-on NL4FC. There are various models, but these are the latest ones. The pins are actually there, they're just shrouded, and this is one of the things that makes these an extremely safe and reliable connector. They're also locking. A word about loudspeaker cable. It's important to use the heaviest gauge loudspeaker cable that you can afford, and also to keep it as short as you possibly can. If the run from your loudspeakers to your amplifier is 10 meters, don't have a 50-meter loudspeaker cable or something like that. You're wasting power and you're generating just excess heat. Now, how do we plug in to one of these? It's important to understand that the speak-on is a locking connector, and it will only go into the amplifier output one way. The way that I always tell people is latch at 11 o'clock. As you can see there, it will only go in with the latch at 11 o'clock. Any other way, it will not. Once you're in, turn to lock. Once it's locked, it won't come undone. To release, you have to pull back on this latch, turn, and then the cable comes out. So I've pulled the camera back a little bit to give you a better view of how this is. You can see we have our mixing console connected to the back of our power amplifier, and then we're now going to connect the power amplifier to the inputs of the loudspeakers. So output of channel 1 to the input of the loudspeakers. The way of connecting on both ends is exactly the same. Latch at 10 o'clock, turn to lock. You can use either of the inputs on the loudspeaker. Once again, they're connected internally in parallel. Now, let's say that you had another loudspeaker that you needed to drive from that channel. How would you do it? You've only got one output on the amplifier for that particular channel. So what you would do is you would simply daisy chain out of the first loudspeaker. So you take another speak-on cable, connect to the output or the link of the loudspeaker, and then run this to your second loudspeaker and connect it there. If, on the other hand, you were only connecting one loudspeaker to each amp channel, you would take the same cable, connect to channel 2, and then run this into the second loudspeaker, and your connection is done. It's a very good idea to make sure that your equipment, especially your power amplifier, is off while you are making these connections, just as a form of cautionary insurance. Finally, a word about setting amplifier level controls, meaning the knobs on the front. A lot of people think that the amplifier should be set to maximum and then the overall level of the system adjusted using the main output on your mixer. This is not actually correct. The reason that you'll see a lot of amplifiers in big systems set to maximum is that that is an easily reproducible level. And very often those systems will include a system processor which adjusts the gain for each amplifier electronically. In a small system, it's important to treat the amplifier level control as effectively the volume knob for your entire system. Everything before that should be running at optimum signal-to-noise ratio using the gain procedure that I've mentioned many times in my videos. The amplifier control is what determines how loud your system goes. So if you play a small venue, it may be lower. If you play a large venue, you may need to turn it up more. The other thing that we need to discuss is this control here, sensitivity. On some amplifiers, this may be labeled gain. On other amplifiers, it may not be present at all. It's internal and not user adjustable. I think that the best explanation for this comes from the good folk at Crown, who make some of the best amps in the world. This is a printout from the Crown Amplifier Application Guide. It's a little bit technical, but I recommend it for you. You can search it on Google. As you can see here, it says amplifier level controls are typically not gain controls. They do not control the amount of gain the amplifier produces. Power amplifiers are designed to produce a set amount of gain. Gain in this case refers to the increase in voltage that the amplifier provides. The function of the level control knob typically is to adjust the signal level coming into the amplifier input stage. The non-technical explanation for this is that it controls how deaf the amplifier is. With the level controls turned down, the amplifier can still reach full rated output power. It just takes more drive level from your mixer to achieve it. So turning the amplifier level controls down doesn't mean that you're going to get less wattage from your amplifier. It just means that you have to hit the input a little bit harder in order to achieve that. So don't think that by turning your amp down, you're robbing your system of power. You're not, all right? So how do we set these controls? Again, the folks at Crown help us. First, make sure your mixer or console is operated optimum signal to noise without clipping the output. Then begin at the 26 dB position. Turn up your amp's level controls until you achieve the desired level of loudness. If it's not loud enough, turn the level controls all the way down and then change the sensitivity switch to the next position. So as you can see here, this particular amp gives us two different levels of gain. You have 26 dB of gain and 32 dB of gain. Begin at 26 dB. If it's not loud enough, go to 32 dB. Well, that's it for this video. I hope the information presented here has been useful to you. As I mentioned, there are hundreds of different brands and models of loudspeaker and power amplifier, so the advice given in this video is quite general by necessity. If you have a challenge or an issue that you can't seem to solve, do please get in touch with me either through the comment section below this video or on Facebook, and we'll see if we can work it through together. This is Bruno Luce for GLB Productions. Thanks for watching, and I'll see you in the next video.